All right, so hope you enjoyed your one-day vacation, I guess. Let me see it. So now we're getting ready for the test. Okay, so I'll let you ask questions as long as you want. I believe Prasanna said he was going to have a review session. He may have already contacted you or emailed you, or maybe he'll put something in the chat later about that. Okay, and tomorrow's test. So you should know all the rules about the test by now. So you know what to turn in. 70% requirement, as you know. Okay, so I'll send over Canvas announcements a little bit after 12, the exam, but I also project it for those of you who prefer to do it that way. And you have until 1 o'clock, or 1 o'clock, I'll end the session. You have 5 minutes to take a picture and submit it by 1:05, and then homework should be in by 1:30. But if you want to submit the homework early, that's okay too. Okay, and then after that, we just have one more test for the remaining 4 weeks. Hopefully, we have plenty of time. I mean, I've got buffer days in. That even includes the Thanksgiving holiday. And then after that, we just have a final exam. Please know our final exam is Wednesday, the 16th of December, and it's 11:10 to 1:40. So you get 2.5 hours to do the final exam. But we'll talk more about the final exam when it gets closer. We're focusing on this test. Okay, other side note, I just emailed or sent through Canvas announcements an invitation for free flu shots. So you can look at that if you want. It's next Wednesday, the 18th, I believe, from 12 to 3 at the Hillsdale parking lot by campus. So you can get more information from that flyer that I sent in the announcements a little while ago. It was maybe less than half an hour ago, I think, or maybe, well, less than 1 hour ago, I should say. Okay. All right, so that is that. So I'm going to stop the share. Okay, so if you want to start putting stuff in the chat for questions and answers, you may. Let me get rid of this. And see, lowest exam score is dropped. Yes, and that could be part of the final exam also. So you don't get to drop the entire final, but you could drop part of the final. That's the way I'll say it. Okay, so let me see, 4.1, 57, 4.5, 37, 4.4, 49. And if you want to ask a question of Prasanna's there, you can do that. And Prasanna can, I could be blabbing away, and I don't know that something's in the chat, so maybe Prasanna could answer some of that. So 11, 15, 17. And of course, you probably know I won't be able to get through all of these, but I'll be doing my best to get through these. 4.5. I'm going to have to scroll. 4.5, 37, 4.4, 49, 4.7, 11, 4.3, got that, 4.5, 37, some repetition, 4.4, 25, 4.5, 33, 41, 49, 4.5, 47, 4.4, 53, 51, okay, 4.3, 47, 39, 4.3, I think you're asking for 3. Okay, this is enough. In fact, I may not be able to get through all of these. So I might not get all of them, sorry. I'll do whatever I can, or maybe a mixture of everything that we have here. And that's the best I can do. Okay, so let's go back to sharing your screen. And if you ask me a question that's not in the homework, I'm less likely to do it in the interest of time for everybody. Okay. Okay. Let's see. 4.157. Let's see what that's about. Yeah, sorry, I'm going for what? I'm going for quantity rather than quality. So in order to get as many in as possible. 4.157. Find the absolute max and min Okay, so f of t is equal to 2 cosine t plus sine of 2t between 0 and pi over 2. Okay, I'm going to write this as 2 cosine t plus 2 sine of t cosine t. Okay, so I definitely have to plug in 0 and pi over 2. Okay, so the derivative is negative 2 sine t plus product rule 2 sine t times the derivative of the second, negative sine t plus the second times the root of the first, 2 cosine t, which is negative 2 sine t. Whoops, maybe I'll just do this, plus 2 cosine squared t minus 2 sine squared t. Do that right? Okay, I'll switch everything to cosine. Cosine squared, sorry, switch everything to sine because there's more sines. 1 minus sine squared t minus 2 sine squared t. So there's a lot of negatives. Minus 2 sine t plus 2. Okay, minus 2 sine squared t minus another 2 sine squared t, so minus 4 sine squared t. Set that equal to 0. Write it in order. Negative 4 sine squared t minus 2 sine t plus 2 equals 0. Let me factor out a negative 2. 2 sine squared of t plus sine t minus 1 equals 0. Negative 2. 2 sine t, 1, 1. Minus should go with the plus here, minus there. Does that work? Yeah, I think that's good. Okay, so sine t is 1/2, or sine t equals negative 1. Sine of t is negative 1. That's not possible between 0 and pi over 2. So that's out. So sine of what angle is 1/2? Pi over 6. So I have to plug in 0, pi over 2, and pi over 6. So f of 0, 2 cosine 0 plus 2 sine 0 cosine 0. Cosine of 0 is 1, sine of 0 is 0. That's out. So 2. F of pi over 2. Plug in pi over 2 to here. 2 cosine pi over 2 plus 2 sine pi over 2 cosine pi over 2. Cosine pi over 2 is 0. Cosine pi over 2 is 0. 0 plus 0, 0. And f of pi over 6. 2 cosine pi over 6 plus, it's probably easier in this case to plug in here. So 2 times pi over 6 is pi over 3. Okay, cosine of pi over 6 is radical 3 over 2. Sine of pi over 3 is also radical 3 over 2. So that gives me 3 radical 3 over 2. It's a little bit more than 5. Okay, so I have 2, 0, and 5. So absolute min is at pi over 2 comma 0. Absolute max at pi over 6. 3 radical 3 over 2. And in general, leave your answers as exact, meaning leave square roots as square roots, leave pi as pi, leave e as e. Only change it if you need a decimal approximation for stuff like this. Okay. All right. So that's it for that one. Took up a lot of time already. Okay, let's see. 4.3, a lot of stuff was asked for. Let me just show you this again in case you didn't get it. It should be on the recording anyway. Okay, 4.3, a lot of stuff was asked for, so I don't know how much I need to do for that. Okay, 4.3, 11. X to the fourth minus 2x squared plus 3. Okay, f prime, 4x cubed minus 4x, which is 4x times x squared minus 1, which is 4x, x plus 1, x minus 1. F double prime is 12x squared minus 4. Set y prime equal to 0. I get x is equal to 0 and plus or minus 1. Plug in 0, you get 3. This is going to be an even function. Same thing if I plug in a positive or negative. If I plug in plus or minus 1, 2. So negative 1, 0, 1. Okay, if I plug in a super big positive or negative, it's positive. Whoops, I take it back. No, that's not right. That's positive. This should be negative. Negative, positive, negative. Decreasing, increasing, decreasing, increasing. So min, max, min. Okay. So f is decreasing from negative infinity to negative 1. Union 0, 1. Increasing from negative 1 to 0. Union 1 to infinity. So minimum, minimum. So plus or minus 1, 2 are min. And 0, 3 is max. Okay. I think to save time, I'll just quickly say, I set that equal to 0. X squared equals 1/3. So x is plus or minus square root of 1/3 for possible inflection points. F of plus or minus radical 1/3 is, let's see, 1/3 squared is 1/9 minus 2/3 plus 3. I think that was 3 minus 18. Oh, I don't need 27. I'm sorry. 9 is good enough. I think it was 22 over 9. We did it before. 1 minus 6 plus 27. Yeah, 22 over 9. Double prime was 4x, 12x squared minus 4. Negative, positive, positive, concave up, concave down, concave up. So, save time, I won't write the integrals of concavity, but we do have inflection points at plus or minus radical 1/3, 22 over 9. Okay. So we had 0, 3. It's going to be a rough sketch. Inflection point, inflection point. 1, 2, and 1, 2. Okay, so. Okay, so that's as much as I want to do for that one. Okay, I'm not sure if I have time to do a whole lot more of these curve sketches. 15, 17, 21, 40, I have to pick and choose here. 41, 45, okay, 47, Yeah, there's just no way to do all these. Somebody asked for 3, but 3 was not assigned. Let me see what I'm going to do here. Okay, well, I've shown you one curve sketch. I know the rest are curve sketches. That's all the time I have, unfortunately, for that. So if I have time later, I might come back to more 4.3, but sorry, I don't have time for that. 4.4, L'Hopital's rule. Let me see. 4.4, 49, I think I already did that. 25, okay, I did not do that one. 4.4, 25. Okay, radical 1 plus 2x minus radical 1 minus 4x all over x. Okay, you don't have to do L'Hopital's rule. In fact, the directions say if there's a more elementary method, then consider using it. Okay. L'Hopital's rule does apply. It's 0 over 0, but this gets very messy. Instead, we'll play the conjugate game, right? So radical 1 plus 2x plus radical 1 minus 4x. 1 plus 2x. Go like that. Okay, so this becomes 1 plus 2x minus 1 minus 4x over x times radical 1 plus 2x plus radical 1 minus 4x, like that. 1's cancel out. So I'll save some time. The numerator is 6x. 2x minus a minus 4x. 1's are gone. So all of this, to save time, sorry, it's going to be 6x, and that x cancels that x. Okay, so that's the basic idea behind that. So limit x approaches 0, 6 over radical 1 plus 2x plus radical 1 minus 4x. Okay, now you can plug in 0. So 6 over radical 1 plus radical 1, which is 6 divided by 2, 3. Okay, so that's 25. 49, I'm pretty sure we did. 51 and 53. Okay. I mean, they're similar. I'm just going to do one of them. I'll do 53. 53. Limit as x approaches 0 from the right. One over x. I'm leaving a space. 1 over e to the x minus 1. Okay, so get a common denominator. Right here. X minus 1, e to the x minus 1, x over x. Limit x approaches 0 from the right. Okay, so the denominator is x times e to the x minus 1. Numerator, e to the x minus 1 minus x. Okay, so now it's something over something. Plug in 0, 0 over 0. So by L'Hopital's rule, limit x approaches 0 from the right. E to the x minus 1. Product rule. First times derivative of second plus second times derivative of first, which is 1. So if I plug in 0, 0 there, that's 0. That's 0, 1 minus 0. Again, it's 0 over 0. One more time. Derivative of the top is e to the x. I know I don't have to do it anymore because when I plug in 0, I don't get 0. So this will be the last time I can do that. Okay, product rule. First times root of the second plus second times root of the first plus derivative of e to the x is e to the x. Okay, now I plug in 1 over, that's gone, 1 plus 1. So it looks like 1/2 is my answer. Okay, I think that's all I can afford for 4-4. 4-5 is more curve sketching. I want to do at least one optimization problem. 4.7. 4.711, I'm pretty sure we did that one. And 37, I did that one also in class. So sorry, I'm not going to do those to save time. So please check the videos from, or your notes for 4.711 and 37, whoever asked for that. Okay, so maybe I will spend more time on the curve sketch. Let's see which one I'm willing to try. 4.5. So 37, 43, 41, 49, 47. Okay. And by the way, for 47, or for 4.5, 47 wasn't assigned. It's every other odd. So take that off the list. Which one should I want to do here? Choose. 41, I think I did. Okay, let me set up 49. 49 from 4.5. Y equals ln sine x. Okay, it is periodic, so I'll just limit to what we need. Okay, let me just draw quickly the sine function. It's a sine, right? 0, pi, 2 pi. Now, I'm only allowed to take natural log of positive quantities. Okay, so that's out. Open circle, open circle. Okay, so the domain is 0, pi, union 2 pi, 3 pi, union going the other way, negative 2 pi, sorry, negative 3 pi, negative 2 pi, and so on. Okay, so if I keep going, right, I throw out all of these guys here. Okay, so I'll get a graph between 0 and pi, nothing between pi and 2 pi, and it keeps doing that. So I'll just analyze between 0 and pi now. Okay. And let's see, that being the case, I can't have any intercepts. Okay, I can't let x be 0, and well, actually, I take it back. I have to see what happens here. Okay, so I can't plug in 0 here, right? Sine of 0 is 0. I'll be taking ln of 0. Okay, so intercepts x equals 0. We can't. How about y equals 0? Maybe we can get that. So 0 equals ln sine of x. Let me move the book out of the way because it's heavy. Exponentiate. 1 equals sine x. That's okay. X is equal to pi over 2 plus 2k pi. So pi over 2 plus 2k pi, comma, 0. So pi over 2, 5 pi over 2, 9 pi over 2, negative 3 pi over 2, and so on. That's intercept. Okay, let's see, any symmetry? F of negative x is ln of sine of negative x Let's see. Equals ln of negative sine x. And that's not possible. Okay, because if this comes out to be positive, this comes out to be negative, which is not allowed. Okay, so there's no symmetry. And let's see about asymptotes. When x approaches 0 from the right, so 0.001, y approaches negative infinity. Okay. And how about x approaches 0 from the, how should I do this? Okay, x approaches 0 from the left, I can't do that. X approaches pi from the left. Y approaches negative infinity also. Okay, so close to pi might be easier to think degrees. That's like 179 degrees. Okay. The y coordinate is very small. So again, I'm taking ln of a very small positive number. So yes, that approaches negative infinity. Okay, so there's a function. The derivative is 1 over sine x times cosine x, which is another way of saying cotangent of x. Y double prime is due to that is negative cosecant squared of x. And that's going to be less than 0 when defined. Okay, that means it's going to be concave down. Concave down. Where it's defined. So I look at y prime, cotangent x, which is cosine x over sine x. Set it equal to 0. A fraction is 0 when the top is 0. So when does that happen for where we're defined? X is pi over 2. Okay. The function value at pi over 2. That's pi over 2. ln 1, which is 0. Pi over 2, 0. Okay. And let's see, sign chart. Well, you know what? We actually don't need a sign chart. We have something faster. We already know it's concave down, so that automatically makes this a map. And I have asymptotes already here and here. Okay, so we have one period offset. Okay, so how should I do the graph? Like this. So 0, pi, 2 pi, 3 pi, negative 3 pi, negative 2 pi, negative pi. Okay, so pi over 2, 0 is a maximum. Okay. Asymptote, asymptote. No graph here. And then it just keeps going like this. And by symmetry, no graph, or not symmetry, I should say. And sine is these are all going to be negative. I take it back. I take a sine of negative theta. So, yeah. And this branch right here, and so on. Okay. All right, so that's as much as I can do. What time is it? I don't have that much time left. Okay. Not sure if I want to do another curve sketch, or if I have something else, then I'll do something else rather than curve sketch, because that might take up the rest of the time. Let me stop the share and see if there's anything else from the chat that I haven't already gotten. But I know a lot of you had curve sketches. We just can't do them all. Sorry. 4.449. Okay, I think I did that one. 4.27 or 17. Okay. We haven't talked about that in a while. Mean value term. Okay, so let me see what I'm willing to do there. Sorry, this process is never fast. Okay, 4.2 mean value theorem, 7 or 17. Four point two seven. So this is a Rhodes theorem. Find R number C that satisfies including the Rhodes theorem. Okay. So sine of x over 2, pi over 2, and 3 pi over 2. It says x over 2. I'm going to write it as half x. Pi over 2, 3 pi over 2. Okay. We can find a derivative everywhere, so that means it's continuous on the closed interval, differentiable on the open interval. And let's see, f of pi over 2. I'll be taking the sine of pi over 4, which is radical 2 over 2. Plug in 3 pi over 2. Half of that is 3 pi over 4 equals radical 2 over 2. Okay, so that fits. All right, so there is a c somewhere between pi over 2 and 3 pi over 2, such that f prime of c is 0. Slope is 0 somewhere in the middle. Okay. So derivative sine of half x is cosine half x times 1/2. That is equal to 0. So I'm basically doing cosine of half x equals 0. And I want an angle between pi over 2 and 3 pi over 2. Pi will do. Okay. X equals pi, because cosine of pi over 2 equals 0. Okay, so we found such a value. Right. And let's see, do I want to do 17? Mean value theorem. F of x equals blah, blah, blah. So that there's no value of c that satisfies the mean value theorem. Okay, and the problem for that is we have a non-differentiable function between 1 and 4. Okay. So show that so and so does not happen. Okay, so this is 1 over x minus 3 squared. We're going from 1 to 4. Okay, so f of 1, plug in 1, what do you get? 1/4. Is that right? -2. Plug in 4 and you get 1. Slope is y2 minus y1 divided by x2 minus x1. 1 minus a fourth over 4 minus 1. 3/4 divided by 3 is 1/4. 3/4 times 1/3. But supposedly there's no slope of 1/4. So Derivative is -2 times x minus 3 to the negative third. -2 over x minus 3 cubed. Set that equal to 1/4. Cross multiply. X minus 3 cubed equals -8. Take the cube root. X minus 3 equals -2. X equals 1, which happens to be an endpoint, but the theorem says it's got to be between 1 and 4. Okay, and no contradiction because f is not continuous between 1 and 4 because 3 is not allowed. Right? So f is not continuous on the interval from 1 to 4. Okay. All right. So now with that, maybe I'll set up one more curve sketching, but I won't be able to finish it because that's all the time we have, unfortunately. Okay, so I have to pick and choose here. 4.3. Which one is worth my trying? Try 15 for you. I haven't got an E one yet. 4.3, 15. E to the 2x plus e to the negative x. Which incidentally is always positive. E to anything is always positive, right? So first derivative is e to the 2x times 2. E to negative x times -1. Second derivative of this is the same thing times 2. So 4 e to 2x plus e to negative x. That's always greater than 0. So the function is always concave up. CD nowhere. No inflection points. Okay, set f prime equal to 0. 2 e to the 2x minus e to the negative x equals 0. Let me write it like this. That's what e to the negative x means, right? And now I'll multiply both sides by e to the x. E to the x, e to the x, 2 e to the 3x minus 1 equals 0. E to the 3x equals 1/2. ln 3x equals natural log of 1/2. X is 1/3 ln 1/2. Quickly. Negative 0.23. I need the y coordinate. E to the, I'm just going to say e to the 2 answer since I got the answer button, plus e to the negative answer. E to the 2 times the answer. I should put parentheses on there. Plus e to the negative answer. 1.89. I already know this is concave up everywhere, so it's got to be a minimum. Okay, so it goes down and goes up. So very crude graph. It was here, 1/3 ln 1/2. F of 1/3 ln 1/2. Always concave up. Could be something like that. Okay, I didn't bother putting the exact value to save time, but you should get an exact value if possible by just plugging in to here. Okay, so that's basically it for that one. How much more am I going to do? Last few minutes. Okay, let me check to see if anybody had a non-curve sketch. Again, from the chat. Nope, doesn't look like it. So back to curve sketching, I guess, for the remaining time. So let's see what I'm willing to set up for you guys, okay? And I know some of you brought this up. I'm not out to get you, so to speak. Okay, I realize, I mean, man, some of these problems just take so long. How can I finish in an hour? So yeah, I'm going to try to construct a test so that you can finish in an hour. We'll see if that comes to pass. But I realize some of these problems take a long time. So I might just have you set up certain parts or say, okay, only do this or don't graph, but show me this, this, and the other thing, or whatever. Okay. So make sure for the directions in the test tomorrow, you do exactly what it says. Don't do any more. So if it doesn't say to graph it, don't waste your time graphing it. If it doesn't say to do, concavity, don't do it. Okay, I just want to test, certain parts of it, so to speak. Okay, last few moments. What am I willing to set up for you? And that's all the time we got, I guess. Let's see. $39 maybe. 4.3. 39. I don't think I touched that one. 1/2 x to the fourth plus minus 4x squared. All right. Minus, sorry. Minus there. Okay. All right, so I'm just going to go turbo here. So the derivative is 2x squared minus 8x, which factors into 2x times x minus 4. Double prime is 4x minus 8. You set f prime equal to 0, 0, and 4. Okay, 0, comma 3, 4, comma, you figure it out. Okay, it's a mess. Okay, sign chart. 2x times x minus 4, 0, 4, negative a million, that'll be positive. Positive million, positive. 2 will be negative. So increasing, decreasing, increasing. Okay, so f is increasing, negative infinity is 0, union 4 to infinity. Decreasing from 0 to 4. Let's see, up, down means max. 0, comma 3 is a max. And 4, comma whatever is a min. Y double prime was 4x minus 8 equals 0. Means x is 2. 2, comma, boy, can I do that? Half of 16 is 8 minus 4, 16 plus 3. I'm going fast, so I could easily make a mistake. I think it's negative 5. 2, negative 5. Okay, sign chart. 2, y double prime is 4x minus 8. Plug in 0, negative. Plug in a million, positive. Concave down, concave up. So f is CV from negative infinity to 2. F is concave up into infinity. Inflection point at 2, comma, whatever it was, negative 5. And there we go. Okay, so I pretty much have it except for the graph because I don't have the function value at 4. I have to plug this in, but I can see it's not going to be very nice. That's all the time we got. Okay, so let me check quickly. How many questions on the test? Well, I don't really say for sure. I'm leaning toward not making it 10 because otherwise we won't have enough time. So it may be fewer than 10, maybe 9, maybe 8, or something like that. Okay. And yeah, I don't have time for anything else, I don't think, folks. Okay, so that'll do it for today. So tomorrow, you know the rules. A little bit after 12, I'll send over Canvas announcement the test, and you turn in your homework. You can start turning your homework now if you wish, but the latest I'll take it is half an hour after the class, so that's what, 1:30? 1:30 tomorrow afternoon. Okay. All right, that'll do it, folks. So have a good afternoon. I'll see you tomorrow. Okay, bye.